Hey, it's Mr. Kingsbury. Welcome to some more notes for my Algebra 2 class. Our unit is dealing with solving rationals. Today we're going to talk about adding and subtracting them. Make sure you put the period and the date on there for you, whatever period you have me that is. And here is our essential question. How do I simplify rational expressions using addition and subtraction? And the answer to that depends on whether or not there is a common denominator already or not. We've got to look at two different things here, whether there's a common denominator and whether there isn't. And then also we need to look at adding and subtracting. So I'm going to do a number of examples here so we can kind of cover all of our bases. I will try and keep this short, but it does take a little bit of time to adjust things, so bear with me. Ultimately with addition, so let's talk about stuff with the same denominator. Denominator. I can spell, I swear. So when they have the same denominator, it's really not as difficult as when they don't, because you don't have to adjust anything. When there isn't the same denominator, then you have to adjust each fraction so that they do have the same denominator, and then go from there. When there's different denominator, or same denominator, you just combine the numerators, and it's pretty straightforward. So let me just give you a couple of addition examples real quick. They go very quickly because addition is a really easy operation to do. You don't have to worry about sign changes and that sort of thing. Like this is ridiculously simple. We've got 5 over x plus 2 plus 1 over x plus 2. I don't know if it gets any simpler. So we would do 5 plus 1 on top. It's still over x plus 2. You don't add the bottom. Don't put 2x plus 4. Don't do that. This is just the same. 5 plus 1 is 6, so we get 6 over x plus 2. That's it. Let me do some more complex ones, though, just so we can get kind of a feel for this. How about something like I'm looking at samples. Can you tell? How about something like this? I like this one. We got x plus 5 over x minus 1. Plus x plus 4 over x minus 1. Something like that. So x minus 1 is on the bottom. I have a common denominator, so that just stays. We don't change anything. On top, we've got x plus 5 plus x plus 4. And all I have to do is combine like terms. X plus x is 2x. 5 plus 4 is 9. And on the bottom, we got x minus 1. Now, it may get a little more complex. Sometimes after you've added stuff, you can factor out something, which happens. And when that happens, sometimes you can factor out stuff and it allows you to cancel, which is actually kind of neat. Let me see if I can show you an example of that really quick. Here, like this. X plus 1 over x minus 2. I meant x plus 2. Plus 2x plus 5 over x plus 2. So our common denominator is x plus 2, and on top we're adding x plus 1 plus 2x plus 5. Well, x plus 2x is 3 x's, and 1 plus 5 is 6. And if you'll note, I can divide both 3x and 6 by 3. If you will, it's a greatest common factor. So if I factor that, I get 3 on the outside, right? I'm going to divide both of those by 3, and I get x plus 2 on the inside. Well, remember that our denominator is also x plus 2. And that happens. That happens sometimes. Not a big deal. But I wanted to show you that, hey, it does in fact happen. Let me show you some subtracting ones. So this is adding. Now how about some subtracting? So here's example 4. Let's say I'll keep it simple. 7 over x minus 3 minus 4 over x minus 3. So once again, same denominator. So we just copy that. And then on top I have 7 minus 4. Well, 7 minus 4 is 3. So I get this. Probably I should circle all of my answers, huh? That one's pretty straightforward. Not a whole lot of challenge to it. How about another one, though, that's a little bit more challenging? And I won't throw in this extra canceling stuff, but well, maybe I will. But it does a lot with other things as well. Or with, I should say with subtraction as well. Yeah, I'll throw one in a second. Anyway, let's do this. What if we got 2x plus 3 over x plus 4? Actually, let's do 7x plus 4 minus x minus 5 over 7x plus 4. Again, same denominator, common denominator. Here's something that happens, though, that's interesting. So the denominator is 7x plus 4. That hasn't changed. We haven't needed to adjust anything, so we're good there. What does change, though, or what we do need to pay attention to is that we're subtracting this whole fraction from this whole fraction. So here's 2x plus 3, and I am subtracting x minus 5. And it's what happens a lot is people will subtract the x, but they will forget that they're also subtracting the negative 5. And so the signs aren't handled appropriately. What should happen is while the bottom remains the same, 7x plus 4, on top we should have 2x plus 3 minus x, and then this will be minus a negative 5. And I just realized you can't see what I'm doing. So probably would be nice if I moved that up for you. Sorry about that. There you go. So I wrote this out. I just rewrote it with 1 over 1 denominator. Here's the top. And now I'm adjusting for the sign. And I put these things in parentheses so I would know what came from which fraction. So I can drop the parentheses part. No big deal. I'm subtracting all of this, though. So I need to subtract x, and I'm subtracting negative 5. And see what happens? I've got 2 negatives. Well, 2 negatives make a positive. So this is really plus 5. Now, when I put my like terms together, I've got 2x minus x. That leaves me with just x. And then I've got 3 plus 5. That's 8. And then that's over 7x plus 4. That'll be my final answer there. Okay, let me do one more here with the same or common denominator, and then I'm going to show you what we do when there are different denominators. So here's our last example, example 6, which is pretty amazing. Let's do, we're going to do 5. Man, I keep breaking my pencil. 5 over x plus 5 minus, I think we're going to do x plus 30. Over x plus 5. Once again, common denominator, so whatever I'm going to write is going to go over x plus 5. Good. On top, this is 5 minus x plus 30. And I have to adjust for this minus. So this is, I'm going to write it down here. So this is 5 minus x. Oh, wow, that's not what I wanted. I meant to make this a 5x. My apologies. Sorry about that. A little adjustment there. So 5 minus 5x minus 30. And you have to adjust for all that, and that's over x plus 5. And actually, I meant for this to be a minus 30. I'm just making all kinds of adjustments, aren't I? My bad. Anyway, then when I put like terms together, on top I have negative 5x. Oh, you know what? I did mean for this to be a plus. My bad. Sorry, this is what happens when you catch an error halfway through your video. So negative 5x, and then I can put 5 and negative 30 together. That would be negative 25, and that's still over x plus 5. And then if you'll notice, I can factor out a negative 5 from this. Yeah. So I get negative 5 times x plus 5 over x plus 5. And once again, those cancel, and I get negative 5 as my answer. And that took a lot of work, and I apologize for that. So there is that. Now let's talk about what to do when we don't have like terms or like common denominators. And sometimes these things, let's see, how do I want to say it? Sometimes they work themselves out, and other times they don't. We're going to have to adjust so that there is a common denominator. These can get really, really intense. We're going to steer clear from some of the intense stuff, like a lot of the intense stuff, because we don't want to make this too overwhelming, I promise. So what would we do? Well, if there's not a common denominator, you need to factor the denominators first. And in fact, usually it's a good idea to factor everything. I didn't give you any examples up here where we factored anything or everything. But it's usually, well, it's a good idea to factor the denominators, not the numerators. You factor the numerators afterwards. I'm going to try and be even more confusing in the future. Sorry about that. Let me say it again. Factor your denominators always if they are not common denominators. If you've got common denominators, just start combining the numerators. If they're not common denominators, factor the denominators first. And then a lot of times if you do that and then you factor the numerators, some things will cancel and then you can go from there. They work themselves out or what have you. Other times, if you factor, it will help you figure out what you need to multiply the fraction by to adjust it. And let me see if I can give you a couple examples of that. So this would be non-common denominators. What are we on? Example 7? Lots of examples. All right, so what if we did say 14? I'm getting so tired of my lead breaking off. 14 over x plus 9 plus 2x minus 4 over 5x plus 45. So the first thing I'm going to do is try and factor my denominators and go from there. This first fraction, there's nothing to factor. X plus 9 is x plus 9. 14 is on top. In the second fraction, though, I can factor a 5 out of this. When I do, that leaves me with x plus 9. 45 divided by 5 is 9. And then on top, if you'll, on top we'll just put 2x minus 4. You know what? On top here, I can factor out a 2, and that leaves me with x minus 2. Sometimes you factor out and you realize that these cancel, which is awesome. Other times they don't so much. So I don't know if that's going to be helpful or not. All these different things you have to look for. Anyway, so we factored that out. Life's good. If you notice, my denominators here, both x plus 9. This just happens to have a 5. So if I multiply the top and the bottom here by 5, then I will have common denominators. 14 times 5 is 70. And on the bottom, I'm just going to put 5 times x plus 9 plus 2x minus 4 on the top over 5 times x plus 9. And those are common, so I can put it all over one denominator. So 70 plus 2x minus 4 over 5 times x plus 9. And then I can do some stuff on the top here. I put like terms together. So I've got 2x on top, and 70 minus 4 is 66. And that's over 5 times x plus 9. You can factor the top. You can factor out a 2. So you get 2 times x plus 33 over 5 times x plus 9. And unfortunately, none of that cancels out. I mean, that would be pretty awesome if it did, but it does not. So, we tried. It didn't work. So we'll move on to something else. Let's see. What if we had something like... let's do... How about like x plus 2 over 3x plus x minus 4 over 5x. You'll notice they're not the same, but they're not terribly complex. They're just a single term. This one's being multiplied by 3. This one's being multiplied by 5. They have an x in common. So here's what I would do. I would figure what's a number that 3 and 5 have in common? That would be 15. So I think I want to make my common denominator 15, and I'll just make an x. The x is already in common. We don't need to worry about that. We just need to adjust the number here. 3 times 5 is 15. So if I multiply everything here by 5, and if I multiply everything here by 3, I'll get 15 x's on the bottom. And then on the top here, I can distribute this stuff. So when I distribute the 5, I get 5x plus 10. And if I distribute the 3, I get 3x minus 12. And then I can write them over one denominator, and that is 15x. On top, I have 5x plus 10 plus 3x minus 12. And I'll put some like terms together. 5x's and 3x's is 8x's. 10 and negative 12 is negative 2. And that's over 15x. You can factor out a 2 on top. When you do, you get 4x minus 1, and that's over 15x. And unfortunately, nothing there simplifies. That's about the worst that you'll have to do. There is one on the test that looks a little bit like number 1, where you factor out the bottom and you factor the top, and the more complex part actually cancels out real nice, and you're stuck with numbers that divide real pretty. So you do have to look for those things. Let's do a subtraction one, just so we've got all our bases covered here. Like this one. We'll make this the last one because I know I'm belaboring the point here, or I'm taking a long time. That's okay. You know what? I don't want that on top. I'm changing my mind. Let's do 2x plus 1 and 3x minus 5. Ooh, I like that. And then on the bottom, 7x plus 14. Non-common denominators. The tops, I don't know why I put parentheses there. Maybe because I like parentheses. Just like that. Now I feel better. So the top does not factor out to 3, and that leaves me with x plus, and that leaves me with x plus 2. Whoops. Please note, I have x plus 2 in common. This has a 3, this has a 7. So all I have to do is figure out a number that both 3 and 7 go into evenly. How about 21? So we can make 21x times x plus 2 our common denominator. And all I have to do is multiply the top here by 7 and the bottom by 7. And multiply the top here by 3 and the bottom by 3. So I got my common denominator there. 7 times 2x is 14x. 7 times 1 is 7. Minus 3 times 3x is 9x. 3 times negative is negative 15. Once again, over 21 times x plus 2. Now I can write them all over one denominator. 21 times x plus 2. And on top I have 14x plus 7 minus 9x minus 15. And I put the parentheses so I can see which one's coming from which fraction. Now I'm subtracting all of this. So when I rewrite it, the first part, 14x plus 7, That stays the same. But right here, I'm subtracting 9x, and I'm subtracting negative 15. Those two negatives cancel out and make it a plus. On the bottom, I still have 21 times x plus 2. Now I can put like terms together. So 14x's minus 9x's is 5x's. And 7 plus 15 is 22, which is not factorable. That's okay. That's going to end up being my final answer. So there you go. We will do more practice in class. This is about as difficult as it gets. But I want to make sure that we practice plenty of problems so that we all, come to we all get this pretty well. All right? All right. I'll see you in class.